Chapter 1, Introduction to Python. In this chapter, we'll explore what is Python, setting up Python, basic syntax. Did you know? Imagine being able to whip up a web application as easily as you can deploy a machine learning model. Python makes this possible. It's like having a Swiss Army knife that's both friendly to new users and powerful for veterans. Take Netflix, for example. They use Python for its content recommendation algorithms because of its quick development time and scalability. Without Python, many companies would struggle to create solutions as fast or adaptively. Remember, Python's strength lies in its community and adaptability, not merely its syntax. However, a common mistake is underestimating the power of libraries like NumPy or Django, which can transform how you approach problems. Imagine wanting to bake a cake without a kitchen. Impossible, right? Setting up Python on your computer is like building that kitchen before starting to code. First, you download Python from the official website, making sure you pick the right version for your system. When installing, remember to add Python to your path, allowing you to run Python programs from any terminal window. Check your setup by verifying the installation using a simple command. Then, dive into coding by installing an integrated development environment, IDE, a coder's best friend, where you write and organize Python scripts. Finally, test your setup by running a sample script. It's like the moment you light the oven, ready to bake. Missing any of these steps is like baking without preheating. It just won't cook right. Imagine assembling IKEA furniture without the instruction manual. Python's syntax serves as that guide, ensuring all pieces fit perfectly. At its core, Python uses indentation to define blocks of code, much like how paragraphs structure writing. For instance, when Spotify engineers work on their recommendation algorithms, proper indentation is critical to keep complex code organized. Without this, the code becomes a jumbled mess, leading to potential errors and bugs. One common headache for new programmers is inconsistent indentation, which can lead to hours of debugging. Remember, consistent syntax is the foundation of all robust Python applications. You might assume that invisible characters like tabs and spaces are harmless in your code, but in Python, they can be a stealthy source of bugs. Imagine you're collaborating on a project and you're using spaces for indentation while a teammate unknowingly uses tabs. This inconsistency can lead to subtle yet infuriating syntax errors. Understanding the critical role whitespace plays in Python is crucial because it pushes you to develop habits that prioritize code clarity and brush up on your personal tab versus space preferences. This awareness transforms how you engage with code editors, encouraging you to leverage their tools to make invisible characters visible. Great work finishing this chapter. Here are the key takeaways. Versatility supports web development, data analysis, AI, and more, letting you switch roles without switching languages. Indentation is crucial for code structure. Python uses whitespace to define scope, replacing brackets or keywords in other languages. Chapter 2, Variables and Data Types. In this chapter, we'll explore variables in Python, data types, overview, type conversion. Did you know? Imagine you're setting up a user profile system for an app like LinkedIn. You need to store and manipulate key personal details, right? In Python, variables help you do just that by holding data like names, ages, and dimensions. As shown here, when you define a variable like username, you give it a meaningful name and value, a bit like labeling a jar in your pantry. This code showcases how to perform calculations, such as converting age to months, helping us manage user-related logic seamlessly. If you skip this foundational step, your application could fail to track essential user details, leading to inadequate engagement or bad user experience. Always remember that variable names are your friends to maintain clarity and ease of understanding in your code. Imagine you're building a sophisticated calculator app. It would need to differentiate between whole numbers and those with decimals. This is where understanding data types becomes crucial. In simple terms, every piece of data in Python is stored with a type, like a container, ensuring the right operations go to the right kind of data. For instance, when you use Facebook to count your likes, it tracks the number using integers. Without using the right data type, you might end up trying to subtract words from numbers, which would cause an error. The most common mistake is not considering the operations you plan to perform and ending up with type mismatches. Imagine you work with an app that lets users enter numbers as text fields, like age or item prices. How do you turn that text into something useful that you can actually compute with? This is where type conversion shines, transforming data from one type to another. For instance, when a user inputs their age as 25, the system doesn't see this as a number until we convert it. Companies like Spotify utilize type conversion to process user interactions stored as plain text into actionable data. Without these conversions, arithmetic calculations or data assessments would fail, leaving you with errors or meaningless operations. Remember, forgetting to convert data types when needed, like adding numbers, can lead to surprising bugs, so always ensure the conversion matches your intended operation. Most new Python programmers assume that variables hold the values they are assigned, like in many other programming languages. However, in Python, a variable simply points to an object, making it more like a sticky note with a name on it that you attach to a specific value. This becomes particularly crucial when working with mutable objects, like lists or dictionaries, because changes to the object affect all variables referencing it. Understanding this concept changes how you approach error tracing and memory management. It's not just about values, but about what your variables are pointing to. Chapter 3, Control Structures. In this chapter, we'll explore conditionals, loops in Python, loop control. Did you know? Imagine you're baking a cake and the recipe tells you to bake for 30 minutes, but to keep checking if it's golden brown. Conditionals in Python work similarly. They help your program make decisions when outcomes may vary. Think about how Spotify recommends songs. It uses conditionals to match musical characteristics to your taste, like if the tempo exceeds 120, suggest upbeat tracks. Without conditionals, programs would follow a rigid sequence, failing to respond to dynamic conditions like serving soup at breakfast. Remember, a common pitfall is forgetting to properly indent blocks of code following conditionals, which leads to errors. Mastering this allows for more intelligent, responsive programming, just like navigating a flexible decision tree. Imagine you're creating a customized greeting card service. You want to send personalized messages to a list of customers, each with their unique name. In Python, a for loop helps iterate over each name in your list, greeting everyone without repeating yourself. For example, platforms like Spotify use loops to display songs in a playlist as you listen. Without loops, manually processing each data item would be cumbersome and error-prone, especially as the data grows. Remembering the difference between for and while loops is key. Use for when you know the number of iterations, and while when the condition is non-predetermined. One common pitfall to avoid is forgetting to update loop conditions, which can lead to infinite loops. Imagine you're at home, deciding on a menu for a family dinner. You start by listing your favorite dishes. If you find the one everyone agrees on, you stop. That's similar to how a break statement in loops works, cutting through the process as soon as you've found what you're looking for. In contrast, a continue statement might be like skipping over the dishes that are too spicy for grandma without dismissing the entire list. Companies like Spotify use such loop control statements to efficiently sift through vast libraries of songs to serve user-specific recommendations. Without these control mechanisms, we'd either waste precious resources going through unnecessary steps or worse, ignore specific conditions. Remember, while loops are a powerhouse tool, mindlessly iterating through them without controlling their flow could leave your program stuck in unwanted loops or failing to account for the exceptions you really need. You might expect that variables declared in a loop only exist within the loop, but in Python, the loop variable holds on to its final value even after the loop concludes. Imagine you've used a for loop to iterate over a list of numbers. The last number can be accessed even outside that loop. This goes against the scope behaviors in many other languages, and it can lead to subtle bugs if you're not careful. Understanding this can fundamentally change how you manage variables in your programs, encouraging more deliberate variable naming and scope planning to prevent unexpected behavior. Great work finishing this chapter. Here are the key takeaways. Conditional statements like if, elif, and else guide program flow by evaluating conditions. Think traffic lights directing cars. Break allows premature loop exit, useful in searching processes to stop once a condition is met, like finding a specific customer ID. Chapter 4, Functions and Modules. In this chapter, we'll explore defining functions, importing modules, built-in functions. Did you know? Imagine you're an architect needing quick calculations of different room areas as you plan a building. Instead of recalculating each time, you can define a function to do the math for you. A function in Python acts like a personal assistant, handling repetitive tasks with ease, just like how Spotify uses various functions to manage your playlists. Without functions, you'd rewrite logic constantly, making programs cumbersome and hard to maintain. This code snippet shows how a simple function calculates a rectangle's area, automating what could otherwise be hours of tedious work. Remember, functions promote dry, don't repeat yourself. Overlooking them can lead to messy and error-prone code. Imagine you're building a house. You wouldn't manufacture each tool. You'd buy a hammer or a drill, right? In Python, modules are like these pre-made tools. They let you skip the hard work and use existing code for complex tasks. For instance, the math module helps calculate without manually coding every function. Spotify taps into such libraries for algorithms without reinventing code. Without them, coding would be like carving each piece of furniture by hand. Just remember to import only what you need to avoid loading unnecessary code blocks. Imagine trying to cook a meal without basic kitchen tools, like a knife or spoon. Python's built-in functions are those essential tools for coding. They make your life so much easier. In simple terms, built-in functions are predefined actions you can use without reinventing the wheel. For instance, when you use Spotify to shuffle your playlist, under the hood, there's a lot of sorting and randomizing happening, all powered efficiently by built-in functions. If you had to write your own functions for these tasks, you'd likely introduce errors and burn valuable time figuring out logic that's already smoothly handled by these built-in tools. Always remember, built-in functions are your first stop for reliable, tested, and optimized solutions. Skipping them is like ignoring a clearly marked shortcut. When defining recursive functions, many beginners assume they can recurse indefinitely like a loop. However, each function call adds a layer to the call stack, which has a finite size. For example, calculating factorials with high input values might cause a stack overflow long before a loop would exhaust memory. Understanding this helps you optimize recursive solutions, using tail recursion or iteration instead to avoid unexpected crashes and resource consumption. Chapter 5, Data Collections. In this chapter, we'll explore lists and tuples, dictionaries, sets. Did you know? Imagine you're an app developer trying to manage user data. Some details change often, while others remain constant. This is where understanding lists and tuples comes in handy. Lists, with their ability to be modified, can handle changing data like social media posts users might edit or remove. On the other hand, tuples are great for storing static data like geographic coordinates or server connection settings, stuff that stays the same and needs quick access. Without choosing correctly, you might end up with slow, inefficient apps that annoy users. A common trap is using lists for everything just because they're more flexible, which can lead to performance issues when your app scales. Imagine you're a librarian managing a collection of books. You need to quickly access different pieces of information about each book, like the author or publication year. This is where a dictionary in Python shines, acting like a real-life catalog card. In our example, we've created a dictionary that stores details about To Kill a Mockingbird. You can swiftly access specific pieces of information using keys, such as title or author. This is not only efficient for lookups, but also makes your data structures neatly organized. Without dictionaries, managing related pieces of information would be cumbersome and error-prone, especially as your collection grows. As people often forget, dictionaries are mutable, meaning you can update their contents even to make sure no one is on your guest list twice. This is where sets come in handy. In plain English, a set is a collection that holds unique items, meaning it automatically removes duplicates. Just like if you tried to add the same person to your guest list again, but realized they're already invited. Instagram, for example, might use sets to ensure no user appears twice in your suggestions or search results, constantly updating and streamlining the data you see. Without sets, we'd need to manually filter out repeats, slowing down data processing and increasing the chance of errors. Remember though, sets prioritize uniqueness over order, so don't expect to retrieve items by position like in a list. One common mistake to avoid is trying to index a set, which simply won't work because order isn't preserved. Instead, embrace the power of sets for their speed and efficiency in ensuring data uniqueness. Most beginners think sets are just like lists, but without duplicates. However, they're essentially the unsung heroes when it comes to handling mathematical relationships between different data groups, such as students enrolled in different courses. If you've ever needed to quickly find common items between data points, or subtract one collection from another, sets can execute these operations effortlessly in a clean and efficient manner. Understanding this capability allows you to solve complex data relationship problems with simplicity, transforming how you approach data analysis and manipulation. Chapter 6, File Handling. In this chapter, we'll explore reading files, writing files, exception handling. Did you know? Imagine you're working at a digital marketing agency and you need to process a list of clients from a text file. Reading files in Python is like unlocking a treasure chest of data. It allows you to access and manipulate information stored outside your program. In this example, we open a file called example.txt in read mode using a context manager, which ensures the file is properly closed after reading. Companies like Spotify read configuration files to manage their recommendation algorithms efficiently. Without this ability, data would remain siloed and inaccessible, hindering your capacity to analyze or use it effectively. Remember to always handle exceptions when dealing with files, as they might not exist or be unreadable. Imagine you're planning a vacation and you decide to jot down your itinerary in a text file. Using Python, writing files is like dictating your secretary to write your notes exactly where you want them. The code example shows how the open function is used with a context manager with to open a file safely, and write method to add text to it. Services like Google Docs save your data into files so you can access it from any device. Without the ability to write data to files, our applications wouldn't preserve user data, making them utterly useless. Remember, a common mistake is forgetting to close a file, but using with open handles this for you by closing it automatically when done. Imagine you're trying to read an important file, but surprise, it doesn't exist. Exception handling in Python, using the try except block, helps you gracefully manage such errors. Think of it like ordering a product online and ensuring you have a refund policy if it's out of stock. Without having exception handlers, a missing file or a mistyped file name would crash your program instantly, just like an unexpected error page on a website. For instance, Spotify might use such handling to ensure it doesn't crash when a song is removed due to licensing issues. Instead, you get a friendly notification. Having these in place not only improves the user experience, but ensures your program runs smoothly even under unexpected conditions. Remember to always handle specific exceptions for better control, like knowing when to expect network downtime versus a missing file. Many beginners assume that hitting the end of a file while reading line by line or character by character will trigger an EOF error, but in reality, Python just returns an empty string or an empty list without raising any error. This is because hitting the end of a file is a normal and expected operation in file handling, and Python's design philosophy supports smooth processing without abrupt error interruptions. Understanding this can change how you approach reading files. Instead of designing cumbersome error handling for what you think are exceptions, you can focus on utilizing Python's straightforward EOF handling to implement more elegant and efficient file operations.